We know these percentages are everywhere. And that's what makes it one of my favorite things to do in math classes. I really use this stuff like all the time. Now, percentages, they're made up of stuff. So if you're thinking about percentages, what are the parts of a percentage situation? So I'm going to take the hard one. Every percentage problem or situation has a percentage. All right, I took that one. Now I'll let you guys get the easier one. So what else is there when there's a percentage situation? If you're going to use a coupon or something, or this person has this statistic, where does this percentage come from, John?
Well, there has to be a unit with every percentage.
A unit, okay. So like of a thing.
That's a great point.
What would we call those things, James? What does the percentage represent?
A discount.
Part. So there's a part of something.
A discount.
And if it's a part of something, it's part of a whole. Yes, we got there. So every percentage problem is going to have a percentage, a whole of something, and a part. The whole point of a percentage is to represent part of something, or more than something. If it's over 100%, that's an option too. Now, let's also break down the word percentage. The word percentage literally means per, and what does that word mean in English language?
How many?
Cent. Per 100. Percentage literally means per 100. So when you get 3 out of 4 on a test, a homework check, let's say, you guys already know what's that percentage?
75.
75, which means 3 out of 4 is the same ratio as 75 out of 100. Those two ratios form a proportion, right? You guys seeing that? So it's all, that's why it's here, it's all interconnected. And what are the 3 different ways we can represent a percentage? I'll take the easy one, a percentage, like 75%. What other way, John?
A decimal.
A decimal, 0.75. Joe?
Fraction.
A fraction, right? That's why I had you do that warm-up, right? Multiple ways. The best way for computation in general is the decimal, right?
Yeah.
We can multiply by decimals and stuff. Because let's say it's 75%, you multiply by 75. You're going to get like some big number, right? 75% means less than 1 whole. So that's why you would use the decimal for computation. So let's get into this. I want us to make sure we all have this. The 3 parts to all percent situations, a percent and a whole and a part. And I'm going to ask you in a moment to identify those in a problem. We're looking for a percentage, a part, and a whole. I'm going to have Will tell me what part of this is the percentage. Percentage, part, and whole. What part of this problem is the percentage, Will?
The percentage, how much is 29 out of 3?
I get what you're saying. This one's kind of tough because the percentage is a mystery. That is the mystery here, Will, right? So the percentage is unknown. That's what we're trying to find. So the next 2 things we have to figure out, what is the part and what is the whole? Emma, you got a part for me? Which part's the part? 3 is the part. Process of elimination. 29 is the whole. Now, I want to make a point, though. The part will not always be less than the whole. There are, like, more than 100% for things, right? It's a possibility. Like, you know, I would say James's effort in class, 110%, right? More than 100%? Yeah. No, that's kind of...
James is going 90%. I'm just kidding.
Oh, that's not nice. All right, so we have our 3 parts. Now, I'm going to warn you, when I was in school, my teacher showed me there's like 3 different things we could solve for, and my teacher showed me 3 different things. I'm not showing you 3 different things. I want you to understand what's happening, and we can just use these words to make an equation. If you try to memorize these situations, you're not going to do well. I'll promise you that. I've seen it enough for 10 years. These aren't hard problems. But if you try to memorize and just like say, like, when it looks like this, I multiply these. When it looks like this, I divide these. You're going to mess up. Just trust me. So watch how nice this is. I don't know if you ever heard me say this before, but math is communication. And I can translate this little statement into math. Here it goes. What percent? What do you think that would be in my equation? X. I don't know what it is. What percent? Okay, of 29. So what am I going to do with that 29?
Equals 29.
Multiply by 29. Right? If you take...
In parentheses.
Yeah, I do the parentheses because if you wrote an X, it just looks like another X, right?
X 29.
So what percent of 29 is 3? I did nothing but translate my words into math, right? You guys seeing that? What percent of 29 is 3? Now, to figure out the percentage, what is this going to make you do? John?
Divide 29 by 3.
Divide 3 by 29.
Or yeah.
Yeah. To get that alone. Which, you guys would know, like if it was like a quiz or something, right? 3 out of 29. And that's going to give me 0.103. But here's the deal. It's asking for a percent. So this needs to be written as 10.3%. All right? So it's going to pump out a decimal answer. We have to interpret that. 0.103 literally means 103 thousandths, right?
Yeah.
Okay. So if I make that out of tenths, move the decimal over. Okay. Move it twice every time. That's 100 out of 100. Cool. So let's look at one where there's something else missing. If you're following along at home, it is on the canvas.
I have a question.
What's up, Mikey?
What if that question were to be rephrased, and what if it said, what is
Help me out with this. We're going to find the percent, the part, and the whole. What pieces do I know here?
that 41% of 78?
So I got a percent, okay,
And you got a whole.
and a whole. And the question is
What?
the part, right? Yeah. Cool. So this one's different, right? Last time we were finding a percent. Again, we're just going to translate this to math. So 41% for computational purposes, I'm going to use 0.41. 0.41 is 41%. Of 78, I'm going to multiply that. When I multiply by that number less than 1, my number should get smaller, is what?
P.
Yeah, the part equals the thing I don't know. You notice the thing I don't know is in a different spot now? Okay, so 0.41 times 78,
31.
31.98. Let's say the directions say nearest tenth. Nearest tenth would be
32.
32. All right?
Really? Is
So that-
easy?
You saw it was different. Yeah. We're going to get in trouble. Some of you are still going to try to memorize. When it looks like this, I do this. When it looks like this, I do this. I'm going to let you know it doesn't work. And if it works for like one test, and later you get a percentage on a test and you forget it. There's nothing to memorize here, right? Are you guys seeing that? It's just identifying parts and then writing it in words. All right, number 6. Here's the next one I want to look at with you. All right. So, I'm going to have Amelia help me identify. What's the percentage, Amelia?
58.
Okay, so I'm going to percentage. What's the whole?
It's not really.
Yeah, so the whole is the question, right? And then the part,
It's 63.
you guys identify those pieces? Okay, we're going to translate it to math now. 58% of what? So times x is 63.4. 58% of what is 63.4. You can seriously read it from your equation after, that's a good check, right? And what's this going to make us do? It's going to make us divide by the 0.58. Guess what the number one wrong thing I see students do with this problem? What do they do with the 0.58 and the 63.4, do you think?
Multiply.
They multiply because they're trying to memorize. Oh, I see this, I do this. Don't do it. Don't you dare do it. All right? And I get 109.3. Now, you should also be asking yourself, does my answer make sense? And let's think about that. This is like 60%, right? So a little more than half. If I double 63, what do I get?
120.
149.
Or no, let's do it instead. Let's do half of 110. Half of the answer. Where am I?
55.
Is that the ballpark of 63?
Yeah.
Yeah. Like, you can like find obviously wrong answers. So let's say you did 0.58 times 63.4. Let's say you messed up and did that.
Why would you do it?
Well, you'd be surprised, man. It happens. And you got 36. Does it make sense that half of 36 is 63?
No.
If you like put your answer kind of back, yeah. So that's an easy way to check to make sure if you're doing the right division, multiplication, stuff like that. All right, we cool?
Hey,
So looking at this first problem, I'm going to have a Zoomer help me.
John and Lennon for
Lily. You're going to help me out with this first problem about babysitting. I don't know if you've ever sat on a baby. Maybe you have. But what I want to know, Lily, you're going to have to unmute. I want you to help me set up the percentage, the part, and the whole, please. For the first bullet. Still muted. I clicked ask to unmute right when you unmuted, my bad. And so then I muted you on accident. There you go.
So if percentage would be 80.
Okay.
I think the whole is X, I'm pretty sure. And part is 12.
Okay, so we have an X. Now is 12 how much? Is that what you're finding 80% of? Or is that how much you make? Because you were making less than your sister, right? Or sibling?
Oh, yeah. So X is part.
Okay, so X is part, 12 is whole. So let's get after it. Another way we could rephrase that is 80% of what the sister makes, 80% of what the sister makes, 12, equals how much you make.
So then you're done.
So, $9.60. Like I was telling them back there, you better have Venmo if you're going to get that kind of change. Or maybe they'll just probably give you $10 an hour now. Maybe that's a selling point. You look so much cheaper because it's not a full 10, but then they're not going to have change, so they just pay you the 10. Side hustle, right? You got to hustle a little bit. Okay, let's look at this one about grades. Nathan, help me out, man. So this is from the first bullet. Second bullet. 15 to 20 students in 8th hour are getting A's. What percentage are not getting A's? So, I'm going to want a percent, a part, and a whole. Tell me what they are, my man.
Is that true?
We know that 75 to 75.
What do I know?
We know that 75% are because of that. Hold on.
Well, look at this, man. Look what the question is.
5 divided by 12?
What percent? So what's the percent going to be?
25.
No, the question is,
Wait,
what percent? Do I know the percent?
yeah. Because
The question says, what percent?
I know.
I'm not looking for an answer. I'm looking to pull the pieces out of the situation here. So
So maybe 0.75.
do I know? Okay. It says what percent in the situation?
75.
Okay, can someone help me out? Joe.
Okay, so this question is it's giving you the part, which is 15, and the whole of the student teacher.
So I got the whole of 20.
Yeah.
I've actually got a part of 5 myself.
And then you need to find the percentage.
So what is it telling me the percentage is?
The percentage is X.
Unknown. That's what you're getting ahead of me, Dan. I was trying to get you back. So, in this situation, the percentage is unknown. I know the part of people without an A is 5. Did you see how I had to pull that out of my information a little bit? And then the whole is 20. Now, some of you could have found a percentage of the 15, and then kids with A's and kids without A's should add up to equal what percentage? 100. So, depending, you could have went about it that way. But let's check this out. I know that what percent of the 20 students, 20 times that percentage equal the total of how many students? 5. Right? Because the question says who did not get A's.
And 15 is who did.
And 15 is who did. So what this makes you do is divide by 20. So how many students are there that did not get A's? What percentage? 25%. Yeah. 0.25, 25%. So 1/4 is another way to think about that too. 25% did not get an A. All right, let's go to this last one. 40% of these 8th graders think that Supreme's cool. Okay? It used to be higher percentage than that, but like they lost some clout. Okay?
Supreme just got sold for $2.8
Okay, so
billion.
I'm looking for percentage, part, and whole. John, help me out.
We know that the percentage is 40.
So I got 40%. Okay?
The part is 72.
Okay?
And the X is the whole.
I don't know. So what I know is 40% of the 8th graders, I don't know how many there are of, totals 72. Again, do you see how I can just restate the problem? It's just, and then this is going to make me divide both sides by 0.4. And that makes sense too, because when I divide by a number less than 1, my answer gets larger. And 72 is just 40% of them. That makes sense, that I have 180 8th graders. Right? Cool. We got one more skill we need to practice. I'm going to apologize in advance because I hate it, because it actually does not have a lot of real-world application. We're going to talk about interest. Who could tell me what interest is?
It's like maybe over time.
It is over time, but so what do you get over time?
Or like in the bank when you earn money.
Yeah, so you either get money or you lose money with interest, right? Because like if you have money in the bank, which don't do savings account, interest is trash. You can get 3% interest in a checking account at Lake Michigan. It's a higher interest rate. You can touch your money real quick. Okay, no penalties for over taking out too many times. Anyway, but the things like investments, you earn interest. But if you take a loan, like things commonly loans are taken for, houses, cars, you have to pay extra money for years. Now, that's what interest is, and that's how interest exists in the real world.
I hate it.
And that interest is usually compounded quarterly. Simple interest does not compound, so it actually kind of doesn't exist in the real world. Compound interest is what's happening, but this is a good place to start, and it's a Common Core standard, so we got to do it. So here's how interest works. The amount of money you either have to pay extra or you receive extra is equal to the principal, which is the amount you start with or the amount you owe, times the rate, that's how it's changing, for amount of time, right? So it's principal, rate, and time. And time in this equation is always going to be years. So what if they said for 6 months? What are you going to do with that? How many years is that? 0.5 or half a year. So time is always going to be in years. The rate you're going to use as a decimal. And P is just how much you start. And it makes sense, guys. The money you get or the extra money you have to pay is equal to how much money there is times the rate for amount of time. It makes sense, right? So that's how I would memorize the equation. So let's do this. Let's say Grandma was feeling generous and she gave you $500 for your Michigan 529 plan.
Yes, sir, G-Mom.
Okay? That's for college. There's tax benefits to that, but whatever. And it's compound interest, but whatever. Let's say you can expect an interest rate of 6%. How many years till y'all go to college? If you go to college. You can also use this for like trade school and stuff too.
5.
In 5 years you're going?
And I'm
Care.
buying the PS5 with this money.
Next, well, if
We'll just say 5. Okay, so here's the deal. Here's how this is going to work. The interest you make is going to be equal to your $500 going in there, earning 6% for 5 years. Do you see how it makes that equation happen? Okay? So let's say 500, 6%. For 5 years, that means you're going to make an extra 150. Now, you got to be careful. They could also ask you the question, how much money is in there now? Which, that is not 150. The money that would be in there after 5 years is 650. So always make sure you're answering the question, right? That got some of you on the basketball points thing on the test. Remember that? Some people told me how many points for X, but that wasn't what it was asking. Do you guys remember that? Okay, so be careful. Here's something else I want to show you. And I'm not going to show you every iteration. But let's say you had $200 and you earned $20 in interest and you knew you had a 2% rate. How much time would that take? I'm just going to show you. You only need 3 of the 4 things, right? Does that make sense? So we could solve for interest, principal, rate, or time. So in this case, I know I made $20. I know I started with 200. I know that I earned 2%. I don't know how long I earned that 2% for. Does that make sense? You just need all the pieces but one. So what that means is 20 equals 4t. Divide that by 4. And that would be 5 years. So if you're going to get 2%, set that to $200 off to the side for 5 years. you get yourself a quick, crisp $20 bill. Now in the real world, again, these would compound. So like your 20 would be more, and then that more would make more, and that more would make more. It's actually exponential.
Because like over the years that.
Over the year, yep, it builds into itself like a snowball effect versus this is straight percentage. That's why I'm not the biggest fan of this, but we got it. Sometimes we just gotta do stuff we don't. We'll do the compound thing later when we do exponential functions, and that's cool because that's how things really work, and that's why like I'll let you know personally, I like don't get much cash out of my paycheck actually at all. It all goes into retirement. Because that money makes money, and that money that makes money, and the earlier you can do that, the more time it has to like work, right? So, again, informed decisions based on math knowledge. That's why I want you guys to know stuff. Maybe you don't want to do that, right? You could choose to do things different, but I want you to have the knowledge to make choices. All right, we're gonna get after it. Your homework's on Go Formative.